In this video, we're going to talk about how to actually conduct a hypothesis test. So we're going to be given in the problem what's called a level of significance or an alpha level. And the alpha level is the probability of making a type 1 error. We don't have to calculate or decide the alpha level ourselves. Like I said, it will be given to us in our problems, and it's chosen by the researcher based on the effect of making a type 1 error. So in situations where we want to make especially sure that we are not making a type 1 error, so situations like medical research, where it could be a life and death situation, we use a smaller value for alpha because that makes us more sure of our results. In situations where it's not life or death and it's not quite as serious, then we can have a higher value for alpha. So what we're going to do is we're going to use Minitab to calculate what's called the p-value. And we'll talk about how to do that in a minute. And we compare the p-value that we calculate to the alpha value. And this will tell us if we reject or fail to reject the null hypothesis. Remember from the last video that when we're doing hypothesis testing, we're either rejecting or failing to reject the null hypothesis. Those are our only two choices. So we reject the null hypothesis if the p-value that we found is less than or equal to the alpha given to us in the problem. And we fail to reject the null hypothesis if that p-value is greater than or equal to alpha. So this right here is very important because it tells us how to decide if we reject or fail to reject the null hypothesis. We compare the p-value that we get in Minitab to the alpha value in the problem. And which one is greater determines whether we reject or fail to reject the null hypothesis. Then, if the null hypothesis is rejected, we can say that there's sufficient evidence to support the claim. And if the null hypothesis is not rejected, that means that we do not have sufficient evidence to support the claim. So this goes into forming our conclusion based on our results. So we are determining whether to reject or fail to reject the null hypothesis, and then we use that to make our conclusion. So there's 6 steps to this approach. Our first step is to state the claim, and then we determine, based on that, the null and alternative hypotheses. And we talked about those in the last videos. Then we identify our alpha value, and we think about our rejection rule. So if the p-value is less than or equal to alpha, we will reject the null hypothesis. If the p-value is greater than alpha, we will fail to reject the null hypothesis. Then we do our calculations. So you might remember from Statistics 1 that we have these 3 tests, one sample Z, one sample T, and one sample proportion. And we use proportion, we're going to talk about in the next video, that's when we have a proportion situation, but we use one sample Z and one sample T if we are doing a problem with a mean and a standard deviation. So we use Z if sigma, our standard deviation for the population, is known. And we use T if the sigma is not known, which means that we are working with a sample standard deviation. So we need to identify what kind of standard deviation we are given in the problem. Is it a population or known standard deviation, or is the sigma symbol used? That means we use one sample Z. If we are working with what's called a sample standard deviation, or it says the letter S for standard deviation, then we are going to use one sample T. And we are using Minitab to calculate the p-value. Once we have our p-value, we decide whether to reject or fail to reject the null hypothesis, and then we form our conclusion. So we're going to go through an example here. This is example 9.5. And we have a parking manager for the Los Angeles Dodgers baseball team, and they're studying the exit times for cars leaving the ballpark. And the manager believes that recent changes to the traffic flow leaving the stadium have increased average exit times. So this is a clue to us about what our hypothesis and our claim is. They think that exit times have increased. So we have the mean exit time prior to the changes was 36 minutes, population standard deviation of 11 minutes, And then we have a sample here of 200 vehicles with a sample mean of 36.8 minutes. And we're using an alpha level of 0.05. So we have to take all of this information and figure out how we're going to pull this into the problem. So we're going to start with our claim. Our claim is that the times have increased, or in other words, the times have gotten larger or greater. And so my claim is that times have increased so that the average exit time is greater than what it was previously, which was 36 minutes. So let's write our hypotheses. Just like before, I'm going to start with my alternative hypothesis, and then I'm going to write my null hypothesis. So my alternative hypothesis is going to be that the mean is greater than 36 minutes. So mu greater than 36 minutes. And then my null hypothesis is the opposite of that. So it's that the mean, mu, is less than or equal to 36 minutes. So now I'm going to identify the pieces that I need to put in Minitab. So I'm going to need the sample size, which is 200 vehicles. I didn't highlight that, but I probably should have. My sample mean, which was 36.8 minutes. And then my standard deviation. Now this is a population standard deviation. So I'm going to use the sigma, which that is 11 minutes. And so that tells us that we're going to use z instead of t. So let's see how this works here. In Minitab, I have this open. What we're going to do is we're going to go to Stat and Basic Statistics, and then go to One Sample Z. So notice here we have One Sample Z, One Sample T is right below it. So if I was working with the sample standard deviation, that's what I would use. One proportion is down here as well. So One Sample Z, I'm going to click on that. And then what I'm going to do is change this drop down here. Move this down a little bit. Change this drop down to summarize data. And then I can enter my sample size, sample mean, and known standard deviation. So my sample size here was 200, sample mean 36.8, known standard deviation 11. Then I'm going to check the box that says perform hypothesis test, because that's what I want to do, is perform a hypothesis test. Once I check that box, I can see the space for entering my hypothesized mean. Hypothesized mean is the mean from the hypothesis that I previously wrote. So my hypothesized mean is 36, because that's the mean that's in my null and alternative hypothesis. So I'm going to enter that. Then I click on Options. Now I don't have to do anything with this confidence level box. I would use that if I was finding a confidence interval, but I'm not doing that here, so I can leave that alone. I do need to change this alternative hypothesis box. So I need to make sure that it matches up with the direction that my alternative hypothesis is. My alternative hypothesis is that the mean is greater than 36 minutes. So I need my alternative hypothesis box to show mean greater than hypothesized mean. So I'm going to select that one. Then I click OK to go back to my previous menu, make sure everything here looks good, and then I can click OK again. It's going to ask me about saving. I can do that or set up the autosave if I want to. And And then what it gives me is it gives me the results in this box. I can shrink down this data entry part because I don't need that here for this. So here are my results. Notice it gives me my known standard deviation of 11. That's what I want. It's giving me my hypotheses here, so I can check to make sure that those match with what I wrote for my hypotheses. My alternative hypothesis is that mu is greater than 36. And then it gives me z-value and p-value. So a lot of the problems in my lab will ask you for the z-value, and you would just type in whatever this number is, in this case 1.03. The p-value is what we actually use to determine whether we reject or fail to reject the null hypothesis. So that's what I really need to answer the question. But like I said, if you need to enter the z-value for the question, it is there for you as well. So my p-value here is 0.152. So I'm going to go back and write that down here. Now what I'm going to do with that is I'm going to compare it to the alpha that I'm given in the problem. So my alpha level here is 0.05. And the way that this works is I reject the null hypothesis if p is less than or equal to alpha. Now in this case, looking at my p-value, 0.152, that is not less than 0.05. It is greater than 0.05. So since 0.152 is greater than 0.05, we cannot reject the null hypothesis, or we fail to reject the null hypothesis. So, what does that tell us about our situation here with the parking lot? Well, what that tells us, since our null hypothesis is that the exit times are not greater than 36 minutes, that tells us that the parking manager does not have enough evidence to say that the times have increased from 36 minutes. So our sample data, our sample mean was 36.8 minutes. So we found in our sample of 200 vehicles an average time that was just a little bit above 36 minutes, but not significantly enough above 36 minutes for us to conclude that it was a significant increase from that.